Exploring Pi, Part 4, Multiplying with Ratios by Jeff Simpson. All equilateral triangles have three sides. Each side of an equilateral triangle is the same length. If one side is 1 yard long, then each side is 1 yard long. A yard is equal to 3 feet, so if one side is 3 feet long, each side is 3 feet long. And a yard is also equal to 36 inches, so each side is 36 inches long. If one side is 1 foot long, then the perimeter, that's the distance around, is 3 feet. The perimeter is 3, the side length is 1. If one side is 7 inches long, then the perimeter is 21 inches. Perimeter 21 inches, side length 7 inches. Comparing the perimeter of an equilateral triangle, there we have the perimeter broken up into pieces and put in one big line. Comparing that to the length of one side, the ratio is 3 compared to 1. A ratio always compares two amounts. When we write a ratio comparing the perimeter of an equilateral triangle to the length of one side, the ratio is 3 compared to 1. But usually we omit the word compared, so we could say the ratio is 3 to 1. But usually we omit the words the ratio is, and we just say 3 to 1, or 3 to 1, or 3 to 1. This last ratio looks like a fraction. Comparing the perimeter of this equilateral triangle to the length of one side, the ratio is 21 to 7. (21 to 7) can be reduced to 3 to 1 if you divide each number by 7. So the ratio of the perimeter to the side can be 21 to 7, and that's equal to the ratio of 3 to 1. These ratios are equal. If one side is 1/4 inch long, and by the way, this picture is an enlargement. A 1/4 inch is actually much smaller than this. Then the perimeter is 3/4 of an inch, or 3/4 of an inch. And we can compare the perimeter to the side. That's 3/4 compared to 1/4. A ratio using fractions might be new to you. It works the same as the other ratios. Here we have the ratio of the perimeter to the side, 3/4 compared to 1/4. The ratio is 3/4 to 1/4, or 3/4 to 1/4, 3/4 to 1/4, 3/4 to 1/4. Let's take a closer look at this last ratio that is in the form of a fraction. A number over a number tells us we can divide. So 20 over 5 is the same as 20 divided by 5. And that's the same as 20 divided by 5 written the other way. It works the same when there's a fraction over a fraction. So 3/4 over 1/4 is the same as 3/4 divided by 1/4. And that's the same as 3/4 divided by 1/4 written the other way. 3/4 divided by 1/4 is the same as 3/4 times 4 over 1, or 4 wholes. Remember, we have to invert and multiply. And 3/4 times 4 over 1, we multiply that out, we get 12/4, and divide each number by 4, that equals 3 over 1. So the ratio 3/4 to 1/4 is the same as the ratio 3 to 1. As we have seen, a ratio can look like a fraction. This ratio is 3 to 1. Now there it looks like a fraction. And a side length can also look like a fraction. This side is 1 unit long, but 1 is the same as 1 over 1, or 1 divided by 1, or 1 whole. So the side length is 1 over 1. Now it looks like a fraction. The ratio of the perimeter to the side is 3 to 1. The side length itself is 1 over 1. We could multiply the ratio times the side length. 3 over 1 times 1 over 1 gives us 3 over 1, which just equals 3. 3 divided by 1 is 3. Well, we could multiply them, but why would we want to do that? Because if we multiply the ratio times the length of one side, we get the perimeter. Here's the ratio. That's the perimeter compared to the side, 3 to 1. Now, if the side is 1, which is the same as 1 over 1, and then we multiply, that gives us 3 over 1, which equals 3. Then the perimeter is 3. Let's look at another example of multiplying the ratio times the length of one side to get the perimeter. If the side is 2, then the perimeter, we do our multiplying here, must be 6. Here's another example. If the side length is 5 units, and we can multiply times the ratio, then the perimeter is 15 units. Here's another one. If the side length is 1.5, then the perimeter, let's see. We multiply that times 1.5. Well, what is that? Let's take a closer look at 3 times 1.5. Here's a picture of 1.5 rectangles. And here's another picture of 1.5, and here's 1.5 more. Oh, we've got 3 of them, 3 times 1.5. Let's move those blue boxes. There's 1.5 plus 1.5 plus 1.5. That equals 1, 2, 3, 4.5. We can add them all up and get 4.5, or we could say 3 times 1.5 is 4.5. So if the side length is 1.5, then the perimeter is 4.5. The length of one side here is 1.5, but there's another way of looking at 1.5. There's 1.5. Let's take that 1 and cut it down the middle. Now it looks like 1/2, 1/2, 1/2. That's 3 halves. So 1.5 is equal to 3 halves. Since it is true that 1.5 is the same as 3 halves, then these two triangle side lengths are exactly the same. The perimeter of this equilateral triangle is 4.5 units. There's another way of looking at 4.5. We could take all those rectangles, cut them down the middle. Now we have a whole bunch of halves. Well, how many are there? There are 9 halves. 9 over 2 means 9 halves. So 4.5 is the same thing as 9 halves. And since it's true that 4.5 is the same as 9 halves, then the perimeters of these two triangles are exactly the same. The perimeter is 4.5, or the perimeter is 9 halves. If the side length is 3 halves, and we can do our multiplying now, then the perimeter is 9 halves. With two equilateral triangles, here's another one, you can make a rhombus. Some people call this shape a diamond. The perimeter, that's the distance around, the perimeter of this rhombus is 4 units. The distance across the middle of this rhombus is 1 unit. The ratio comparing the distance around, that's the perimeter of course, comparing that to the distance across is 4 to 1. Here's another rhombus made from two equilateral triangles. The ratio times the distance across will give us the perimeter. If the distance across is 2, here's our ratio. Perimeter to the distance across, the ratio is 4 to 1. Then we can multiply, and the perimeter of the rhombus must be 8 units. And it is. If the distance across is 3 halves, then the perimeter, well, let's do our multiplying and find out what that has to be. 12 halves, that reduces to 6. So the perimeter must be 6. With 3 equilateral triangles, you can make a trapezoid. And with two trapezoids, you can make a hexagon. With 6 equilateral triangles, you can make a regular hexagon. A hexagon has 6 sides. Hex is Greek for 6. Regular means all the sides are the same length. As the part 3 video showed, if every side of each triangle here measures 1/2 unit, then the hexagon is 1 unit wide across the middle. And the perimeter is 3 units. Comparing the distance around to the distance across, the ratio is 3 to 1. The ratio multiplied times the distance across will give us the perimeter. So if the distance across is 1, we do our multiplying. Then the perimeter is 3. If the distance across is 4, we do our multiplying and find out what that gives us. It looks like 12. Yes, and we can see that it is. Then the perimeter is 12 units. If the distance across is 7 units, we'll multiply times the ratio. We get 21. Then the perimeter is 21 units. The distance across this square, right through the middle, is 1 unit. The distance around the square is 4 units. That's 1 on each side. So the ratio comparing the perimeter to the distance across is 4 to 1. If the distance across this square is 7 units, and we can multiply, then the perimeter is 28. Here's a square that is 7 units across, and a hexagon that is 7 units across, and a circle that is 7 units across. The distance across is the same for each shape, 7 units. The distance around is not the same for each shape. The distance around the square, that's the perimeter, is 28 units. The distance around the hexagon is 21 units. And as the part 1 video showed, the distance around the circle, that's the circumference, is 22 units. Here's the ratio comparing the distance around to the distance across for each shape. For the square, the ratio is 28 to 7. For the hexagon, the ratio is 21 to 7. For the circle, the ratio is 22 to 7. The circumference is the distance around the circle, and the diameter is the distance across the middle. Here we see the circle has a circumference of 22 and a diameter of 7. The ratio is 22 to 7. If the distance across a circle is 1 unit, and the ratio times the diameter will give us the circumference, so we can multiply 22 sevenths, that's our ratio, times 1, that's the distance across. That gives us 22 sevenths. And that's the same as 22 divided by 7, which is 3 1/7. So the distance around is 3 1/7. Well, what if the diameter is 2 units? We can multiply times the ratio. 22 sevenths times 2 gives us 44 sevenths, which is the same as dividing 44 by 7. And that gives us 6 2/7. So the circumference is 6 2/7. But what if the diameter is 3 units? Well, we can multiply the ratio times that. 22 sevenths times 3 is 66 sevenths. We divide it and we get 9 3/7. So the circumference is 9 3/7. If the diameter is 4 units, we can multiply that times our ratio. 88 sevenths, do our dividing, and we get 12 4/7. So the circumference is 12 4/7. Here's our ratio comparing 22 to 7. That's the same as, well, 22 divided by 7. And that's the same as, well, let's take a look. Let's do it with decimals this time. 22 divided by 7. Well, that gives it 3. Times 7 is 21. Subtract 1, bring down the 0. Well, you can follow the math. Oh, look at this last part here. We already did that. Oh, so it's going to be the same thing over and over, repeated. So 22 divided by 7 is going to be 3.142857 repeating. 22 divided by 7, 3.14, let's just round that to 2 digits, 3.14. There are more numbers, but we don't need them right now. So we could say 22 sevenths divided both numbers by 7 is equal to 3.14 over 1, or a ratio of 3.14 to 1. So 22 sevenths is approximately the same as the ratio 3.14 compared to 1. These ratios, 22 compared to 7 and 3.14 compared to 1, are equal. And these ratios are both called pi. Here's our circumference going around the circle, diameter going across the middle. Pi is the ratio comparing the circumference to the diameter. That's approximately equal to 22:7 ratio, or approximately equal to 3.14 compared to 1. If the diameter is 10 units, we can multiply times our ratio, given in decimal terms this time, and that gives us 31 4/10. So the circumference is approximately 31 4/10. If the diameter is 100 units, we can use our ratio, multiply it times 100. That gives us 314. And the circumference is approximately 314. Well, there is more to learn about pi, but this is enough for now. So that's all for the part 4 video. Thanks for watching. And please share these ideas with other people who can benefit from them.